So guys, hello again. So this video start to calculate networks diagram. So we have diagram activity. So this time we will calculate the start date and the end date. Either it's early start, early finish, or late start. So network time computation. The purpose of this calculation is to determine one is to find the completion time. This is basic. So you want how many days is needed to complete the project. And the second one is the time brackets. Time brackets within each activity must be accomplished in the completion. So you want to do the early start, early finish, later start, so that you can achieve late finish. Date, you are more concerned about date. So the calculation of each of activity times involves the determination of limiting times for each network activity. So there are limiting limiting or limiting times, limiting times that you consider. So the time are one, the early start early start, or the earliest start, the soonest you can start. The earliest start of an activity is the earliest time the activity can possibly start, allowing for times required to complete the preceding activities. So the earliest you can start activity so that the next activities uh, can start on schedule. Next, the limiting time is early finish, or the earliest you can finish the task. Next one is late finish, or the latest you can start. Let's say you have delay, so how late can you start though? And it connected to late the late finish, the late start. Late start is so how late can you start so you can achieve that late finish. For example, uh, I will see the next one. So first one is the early start. How soon can you start? So things that follow is the finish. So when will finish based on the early start. So the duration is fixed. So when is the earliest you can start, then you can finish. So based on that and based on the end date, it will calculated uh, early finish of each activities, and then you can get the early finish of the project. The finish of the project, so you know the end date of the project. So based on the end date, you can calculate the late finish. So the latest you can finish, and then based on that late finish, you can determine the late start of each activities. So this is important when you trying to find the load each activity. See, say. So this is how you find the spare time each activities. Should that activities have the spare times of float, provided that activity is not on the critical path of the project. So these are all that determined based on the network time computing. So let's take a look at ESEF, earliest start, earliest finish. Start, early finish. So in network diagram for each activity, so early start will be on the left top, early finish will be on the right top. So based on this diagram, activity of start project. So your ES is 0, project start, 0 day, day 0, day 0. Then 0 days, so your early finish will be 0. So duration is 0. So your early finish is also 0 day. So in this example, if you have the next activity, which are order and delivery files, and then main lies in. So your early finish of the uh, previous task will be the early start of the preceding task. So you can see here, this is your early finish will become the early start of the early finish of the first task will early start of the subsequent activity. As mentioned here, ES is equal to EF activity 0. So your ES is equal to 0. Duration is 15. Duration 15. So your EF earliest finish will be ES as here. So ES here plus your duration. So you get your early finish. Very simple mathematics. Let's take a look at the next activity. So activity number 40. 40 activity is move in. So similar start date. Start day 0. So your day 0 is your ES, because S is equal to EF of this activity. Duration is 3 plus 3. So your earliest finish is day 3. In network activity, you also have burst activity, where one activity branches out in subsequent activities. So in this example, once you move in, you want to start fabricate your apartment, for example, apartment form work, and then you can also start excavate your apartment. So your ES of prefabricate apartment forms will be equal to EF earliest finish activity 40, activity 40, which is day 3. So day 3 plus duration 3, so you get your earliest finish is 6. Same goes to this activity 90. ES activity 90 is equal to EF activity 40. So 3 plus 3, day 6 should finish excavating your apartment. There also is another type of connectivity between activity, which is two tasks. You have two tasks. Find two tasks need to be completed before you can start a subsequent task. For example, in this you have fabricate and deliver pudding bar, task 70, and task 110. You need to drive piles to the apartment. So you need to complete these two tasks first, and then only you can start doing rebar and form activity 130. So what happened here is that because of these two tasks having different earliest finish, day 12 and day 18, so you need to take the latest finish, latest day, which is very logic. So in this example, you need to take day 18 as your reference EF. We use as earliest start for activity 130. So as written here, ES of 130 is equal to latest EF of activity 70 or activity 110. So it will be day 18. So day 18 plus 2, which is the duration of fabricating for and rebar thing. So your earliest finish for activity 130 is day 20. Simple as that. So let's take a look at another example. For this example here, as you can see, let's say example on this activity, activity 20. Activity 20, the earliest finish is 0, earliest start is 0, earliest finish is 5. So this 5 would determine this earliest start of subsequent activity. As an example, a direct relationship, one-to-one relationship. Let's say you have a burst activity where one activity is needed to complete, or other 3 activity, for example, other activities to start. For example, in this activity 40, activity period 40, so the earliest finish is day 3. So day 3 becomes the earliest start for activity 80, 90, 100. So as you can see here, on day 3 only, these activities can start. So as this being determined by activity 40, so your earliest finish is also fine. It's on the next duration. So 3 plus 3 is equal to 6. 3 is equal to 6. 3 plus 2 is equal to, so day 5. So as we discussed before, there are also activities that you need to, for example, you need to finish 3 activities in order to start the next one subsequent activities. For example, in this activity 110, 110. So you need to complete activity 30, activity 90, and activity 100. So you need to find the latest, earliest finish. So at activity 30 is 15, activity 90 is 6, day 6, and activity 100 is day 5. So the latest will be this one, this one activity 30. So it will be the earliest start for activity 110. So 15, day 15 plus 3 days of driving piles into abutment. So your earliest finish will be on the day of 80. Okay, guys, let's take a look at the next example. This is also the same example where you have 3 activities combined as a precursor, precedence activity, activity 390. So activity 390 can only start if guardrails have been completed, pane have been completed, and saw joints have been completed. So the latest among these 3 activities is 60. This one. So day 60 is the earliest finish for activity 370 becomes the earliest start for activity 90, despite you having this day 58 and day 53. So another example, let's take a look at this burst activity. So strip and cure abutment, burst into rub concrete abutment, number 2 backfill abutment, and then set girders. So this earliest this earliest start, this earliest finish define the earliest start for these 3 activities. So you can see that for day 43 becomes the earliest start for these 3 activities. So day 43 plus 3, so you get 46 plus 6, 6, 43 plus 2, 45. So I hope it is clear for you to compute the days and activities. So, you know, uh, nowadays we have Microsoft projects, but that requires your subscription. But we also have various types of software project management. But the basic, the fundamental is this. Fundamental is what we are learning. This is a manual method. Can come up. You can also develop this in Excel with the diagram, so you can print out. So you can use uh, draw.io in the internet. But the basic of computation is the basic of relationship. This is what they do. So should you don't have any access to software project or Primavera, so you can develop diagram based on what we have learned in CPM, incidence diagram. So normal activity durations used as scheduling basis represents the most efficient, most economic the normal activity we assume. So you should not estimate your duration the fastest or the longest duration, you should estimate the duration based on the most optimum days required to complete the job. Not too short, not lay back, not strict, not very tight schedule. And shorter activity times usually require expensive expediting actions. Usually in the contract they call this the acceleration clause. Acceleration, accelerate, acceleration. This acceleration clause is usually a client pump up more money so that we can expedite the degree of the project. So usually if you shorten the duration, so you incur more cost to the project. And longer activity time suggests relaxed attitude, but also increase in cost production because you need to rent machine longer days. You need to uh, hire labor longer period, so the cost will be increased because you are hiring days. So having the optimal, certainly job overhead expense increase with the duration of construction project. So this is also in relation with this longer activity. So your overhead cost, office rental, your manager wages, your director's fees, uh, all that sorts of things, that be incurred to your uh, company's financial on monthly basis, that will also increase as the duration is increased. So you need to have the optimum amount of duration. So let's say based on an example project, having established that 70 working days is satisfactory. So satisfactory is 70 working days. Job calculations now turn around on this value. And the second series of calculation is performed to find late start and late finish time for each activity. So let's say we have determined the 70 days complete the project. 70 days. That is the optimum. So now we can find the late start. What is the latest you can start for each activities? What is the latest you can finish so that you still achieve these 70 working days. So this calculations called backward pass. This is called backward pass. Start at the project end, and then proceed backward through the network going right to left. So we do our precedence diagram from left to right. So right now we are counting backwards, computing backwards from right to left. So LSLF, the late start and late finish relationship. So the late activity times to be computed are the latest times at which several activities on highway bridge can be started and finished with project completion still achievable in 70 working days as mentioned earlier. So you want to maintain these 70 working days for the whole project. So what is the latest time for several activities that you can start late? You can start late, finish late, but still the project can finish in 70 working days. So we're counting backwards. This example with the duration of 6. In this example, your finish activity at 70 days. So your late finish, so your early finish, come your late finish, duration is 0. So your late finish for finish task for 0 is 70. So what you do, this 70 becomes the late finish, becomes the late finish for the precedence activity before, which is contingency. On this contingency. So your 70 days late finish minus your duration of this activities, which is 6 days. So your late start is 64. 70 minus 6, 64. Similar. Activity 400 immediately precedes activity 410. Duration of 1, it has an late start value of 64 minus 1, which is 63. This example, final inspection is before contingency. So late uh, late start for contingency 410 becomes the late finish for 400 final inspection. So late finish minus duration, so you get late start. So your late start will be day 63. So this is basically how you can calculate the late start. So next video we take a look on more examples on this late start, late finish, late finish, late start. How we can calculate and then come up with late start for each activity, and then can come up with should there be any example have any, because the early start and late start is similar. So that's all. See you in the next video.